In this lecture, we will be seeing about analysis of a rectangular dam. Okay. Now, previous lecture we have seen what is rectangular dam and what is trapezoidal dam. Okay. So based on this shape, it is classified. For both the dams, we have seen the resultant lateral thrust is P, which is acting at a distance of h by 3 from the base. Now we have to study in detail about what are the maximum stresses developed in this case and minimum stresses developed in this case. Okay, that is sigma max and sigma minimum we have to calculate. So it is very important to understand the geometry here. So pay attention to each and every concept. First of all, we will draw a rectangular dam. So this is a rectangular dam. This is the ground level. The total height of the dam. The total height of the dam is capital H. These dimensions are very important. So pay attention. Now there is some water in the dam which is present, or the dam is retaining some amount of water. So जे water retain करत आहे, this is the level of water. Now the height of this level of water from the base is small h. So this value is small h. Now what is the variation of pressure? We know that variation of pressure is triangular. So this is the variation of pressure, and the resultant pressure or the resultant lateral thrust that is acting, it is P, and it is acting at a distance of small h by 3. It is acting at a distance of small h by 3. Now we'll give some names here. This part of the dam or this point of the dam, this is called as toe of the dam, and this is called as heel of the dam. Okay, this is toe and this is heel. Point A, point B. Now we'll draw one line from the center or from the centroid of this rectangular section. So this is the centroidal line or centroidal axis. Now at the point which intersects here, this point we will name it as point O. So this is A, B and O. Now if the total distance or the total width is B, what is the distance? What is this distance? This will be equal to half of the total distance, because this is the centroidal axis. It is passing through centroid. Let's give the name also for the centroid. So this is the centroid. CG. Now what we'll do is we'll extend this line of action of force. Now as this is made up of concrete or it is made up of some material, this dam will also have some of its weight. काहीतरी weight राहणार त्या स्वतःचं. So that weight will represent by W. So the W represents W represents the weight of the structure or the weight of the rectangular dam. Now there is one more force which is present here, this P force. Now what we'll do, we'll extend this P force. या P force ला आपण थोडंसं extend करू इकडे. Same force. This is the P force. Now at this point, there are two forces that are acting, and these both are perpendicular to each other. The resultant of these two forces will act at an angle of 45 degrees, or we can say that the resultant of these two forces will act in this direction. This is the resultant force. This resultant force will meet this base at some point and we'll name that point as E. ठीक आहे, बघा हा P फोर्स आहे आणि W फोर्स आहे. W म्हणजे वेट ऑफ द डॅम आणि P म्हणजे दिस लॅटरल वॉटर प्रेशर और द लॅटरल थ्रस्ट ऑफ वॉटर. ओके, वॉटर मुळे जो लॅटरल फोर्स एक्झर्ट होतो आहे या डॅम वर, दॅट इज दिस P फोर्स. आता या P आणि W चा रिझल्टंट फोर्स जर काढला आपण, ओके, रिझल्टंट फोर्स जर काढला, so that resultant force will act in this direction and it will meet this point E on AB. So the resultant force is meeting the base at point E. Now we have to see all these dimensions here. Now this distance AO, this distance is equal to B by 2. The remaining distance OB, what is this value? This is also equal to B by 2. Now this distance OE from O to E, this is called as eccentricity E. This distance is E, small e. Now to find out the value of small e, that is position of resultant force. Position of resultant force. So we can find it out by using Varignon's theorem. By using Varignon's theorem. Now this theorem, Varignon's theorem, has been completed in engineering mechanics itself. We'll write that theorem here. What is the statement of the theorem? Sum of moments of all forces at a point is equal to moment of resultant force, moment of their resultant force about same point. बघा सांगण्याचा काय अर्थ आहे की जर दोन फोर्सेस आपल्या केसमध्ये जसं P आणि W फोर्स आहे, या P आणि W फोर्सचा रिझल्टंट काय आहे? P आणि W फोर्सचा रिझल्टंट आहे R. नाउ इफ वी टेक वन पॉइंट, आपण जर एक पॉइंट घेतला आणि त्याच्या अबाउट जर मूवमेंट काढला, मूवमेंट म्हणजे मूवमेंट मीन्स फोर्स इनटू डिस्टन्स. सो इफ वी डू दिस फोर्स इनटू डिस्टन्स ऑफ P and force into distance of W, then it will be equal to the movement of the resultant force about the same point. Now just pay attention here properly. Let's take point E, that is about point E. We'll calculate all the moments about point E. So according to Varignon's theorem च्या हिशोबाने the moment of force W about point E, okay, and the moment of force P about point E is equal to moment of force R about point E. Now we will be taking one by one moments. What is the moment of W about point E? So moment is equal to force into distance, so it will be force W multiplied by distance E. Now for the case, we will take this as positive. That means we are taking anti-clockwise positive. Anti-clockwise movements we are taking positive. So W into E. Now second movement will be there by the P force. So second movement is P multiplied by, what is the distance between P and E? This distance, this is equal to small h by 3. Small h by 3. So this is small h divided by 3. And the direction is clockwise. So we will take is minus. कारण की anti clockwise positive घेतला आहे आपण. So W into E minus PH by 3. This is equal to, that is sum of movements of all forces about a point is equal to movement of their resultant force. आता W आणि P चा resultant force काय आहे? R आहे. So movement of resultant force about point E. But we can see this force R, it is passing through the same point E. That means distance value is 0. So now if we equate it, we will get W into E minus PH by 3 is equal to 0. After calculation, we will get it E is equal to P by W into H by 3. This is the value of eccentricity E. I hope it is clear. This E value is P by W into H by 3. So we can write here a statement. The resultant force R acts at a distance of E from center of base, that is O. म्हणजे O पासनं from this O point, what is the distance of point E? It is equal to small e, and what is the value of small e? P by W into H by